Here we will talk about smooth intestine motility. So the small intestine, contrary to its name, is actually the largest segment of the GI tract, and it consists of three regions: the duodenum, the jejunum, and the ileum. And this is the site in the gastrointestinal tract that is responsible for most of the digestion and absorption that occurs. It is the business end, if you'd like. The function of the small intestine motility is as follows. It is to mix chyme. Chyme is the food contents that are mixed with the different digestive juices, secretions from the pancreas, from the bile, etc. And the motility mixes the food with these secretions to create this chyme. Motility also moves the chyme down the length of the small intestine, and the mixing enables optimum contact with the absorptive surface, the epithelial layer that is folded into villi that has microvilli, and so the motility is to mix and move the chyme down the small intestine for best digestion and absorption. There are several different types of motility in the small intestine, and it depends on whether you've just eaten or not. The digestive motility pattern consists of segmentation, which is responsible for mixing, and peristalsis, that is responsible for propulsion. And then if you haven't eaten for a while, you have this interdigestive motility pattern, which is called the migrating myoelectric complex, that has a housekeeping function. So segmentation is the most frequent type of motility, and these are closely spaced contractions that happen in rhythmic patterns that are responsible for mixing. The frequency of these contractions depend on the location in the gastrointestinal tract, it being more rapid in the duodenum and less so in the ileum, about 11 to 13 per minute in the duodenum and about 11 to 9 in the ileum. And how these work is shown in this diagram here. When you're in one, you can see the segments that are contracted already, and these lines denote where the next set of contractions are going to happen. And so they contract, and you end up in two, where the contractions are now, the segments are in different areas, and you can see the lines where they're going to contract next. And so 3 then follows, as does 4. And although its main function is mixing, these frequency of segmentations allow a slow forward transport of food, particularly enhanced by the different frequency of segmentation in the different sections. This barium contrast X-ray shows you the segmentation of the small intestine. Here we can see the small intestine, and these white patches are full of chyme, and the constriction in the middle of it then is the segmentation, where the ileum has become contracted. If you were to take a picture several seconds later, these contractions would all be in different sections. And that's because of the rhythmic pattern of segmentation. Peristalsis then is what moves, or is the main driver of chyme through the intestinal tract, through the small intestine. And these are progressive contractions of successive sections. They happen over short distances, where the small intestine will contract sort of proximal to the food and relax distally, and then this wave of contraction then pushes the food forward, propulsing the chyme. And what determines these activity, what creates this activity, are the slow waves that come from the interstitial pacemaker cells. So the impulse is intrinsic, and that's what sets the mean frequency of these contractions. The slow waves can be accompanied by bursts of action potentials should the intestine decide that it needs to be a strong contraction. And the intramural nerve plexuses modulate the segmentation and short peristaltic waves over about 10 centimeters. But these are modulated then by the extrinsic innervation that is involved in long-range reflexes. Hormones also modulate smooth muscle excitability and contraction, and again we see these three pillars of regulation: intrinsic, extrinsic, and hormonal, that regulate the frequency and strength of the slow wave contractions. Parasympathetic nerves will enhance them, and sympathetic nerves will generally inhibit the smooth muscle activity in the small intestine. The reflexes are generally passed up and down these plexuses, the myenteric plexus and the submucosal plexus, and this kind of reiterates what we've seen in past. Excitatory is acetylcholine and substance P. Inhibitory is vasoactive intestinal peptide and nitric oxide. So if you haven't eaten for a while, the migrating myoelectric complex kicks in, and this is a pattern of activity that basically sweeps the entire GI tract of its contents. And these bursts last about 5 to 10 minutes, and they're characterized by these intense periods of electrical and contractile activity that propagate from the stomach to the terminal ileum. And they repeat every 75 to 90 minutes. And the function of these waves then is to sweep the small intestine of its contents into the cecum. And this functions together with the ileocecal sphincter to keep migration of the bacteria in the colon and not into the small intestine. And it serves as a housekeeper function then to keep the essentially sterile small intestine clean. So the contractile activity of the muscularis mucosa is something that has quite a high importance in the small intestine. The muscularis mucosa is in the mucosa. It's the basement level, and it's this thin muscular layer that allows folds and ripples to occur in the epithelium. And this changes the topography of the internal surface of the gut to ensure maximum exposure of the epithelial layer to the foodstuffs that are going through. It also facilitates lymph node motility, as the contractions squeeze the lymph nodes and provide motility of the lymph fluid through. And this is important because a large amount of lipids and digestive stuff actually is absorbed into the lymph system. Intestinal reflexes can be both short range and long range. Short range regulated by the intrinsic nerves, and then long range involves intrinsic and the central nervous system. And so we have this law of intestines also exists in the stomach, as we saw in the small intestine, as we saw in the esophagus. And stretching a segment of the GI tract, in other words, if there's food in one area, it's going to be sensed by the enterochromaffin cells that release serotonin, and then you get contraction proximal to the bolus and relaxation distal to it, and this will drive the contents in the arboreal direction. This is again an example of the law of intestine. And so these are several intestinal reflexes that are seen in the small intestine, and these are generally long-range reflexes as opposed to the law of intestine that is short-range. The long-range intestinal reflexes require central nervous system functions, and you have the intestinal reflex, which over dissension of one segment of the intestine tends to relax smooth muscle cells of the rest of the GI tract. This prevents blockages. It just allows the intestine to adapt to large quantities of food. The ileogastric reflex, dissension of the ileum, decreases gastric motility, and that makes sense. So if you have food in the small intestine, you don't want more food coming into it, and so the small intestine feeds back to the stomach to keep the pyloric sphincter closed. And then you have the gastroileal reflex, which is sort of the opposite of that. If increased secretory and motor activity in the stomach will increase ileal motility in order to create room for the contents that's now in the top part of your gastrointestinal tract. And this movement, this motility, includes the ileocecal sphincter. So, talking more about the ileocecal sphincter, it's generally closed, and this is to prevent bacteria from the cecum coming into the small intestine and making it less sterile than it should be. Short-range peristalsis in the terminal ileum will relax the sphincter and allow a small amount of chyme into the cecum. And this then, similar to the pyloric valve, ensures flow in one direction only. You need pressure and food near the sphincter for it to relax and for the chyme to pass through. Dissension of the cecum contracts the ileocecal sphincter, so if there's a large amount of contents in the cecum, that's going to keep it closed. And the gastroileal reflex enhances ileal emptying after eating. And so we talked about if there's stuff in the stomach, then the contractions down to the bottom end of the small intestine are going to increase and push more food into the cecum. The hormone gastrin, which is released in the stomach, relaxes the ileocecal sphincter, and this obviously promotes flow then from the small intestine into the large intestine to allow for space for more stomach contents to be put into the small intestine.